All right, so another one of our soil concerns that we look at is engineering properties. And engineering properties is a bit all encompassing for a bunch of different things. Three of these are going to be covered in other soil concerns. So look at those videos for those. Those being texture, hydrologic group, and depth. So you can look at those to get another idea of some of the engineering properties when they're talking about engineering properties that are concerned. The ones in this that we're going to cover are our unified classification, AASHTO, fragments, liquid limit, and plasticity limit. So I want to start off with unified soil classification. So in order to find out what your unified soil classification is, what you're going to do is you're going to soil properties and qualities for your area of interest. And then you're going to go under soil qualities and features. So do that drop down. And down at the bottom of its list, you'll see unified soil classification surface. So if you view our rating, new idea of looking at the surface soils, um, what that unified soil classification system is. And so unified soil classification system is very similar to our more texturing soils. It's just a different way of numerically putting a different name to it. So instead of saying like a sandy clay loam, you're going to say that it's perhaps an SC. And so it's just a percentage that you're going to see. Um, so when we look at these, what you're going to do is you're going to get your rating, which is that classification based off of percent sand, silt, and clay. So that's going to be usually two letters or two letters with a dash. So SC, ML, SC-SM. And all these mean different things, and they kind of relate, especially for our engineering purposes, to different things that we can use for engineering. Most of the time, this is going to be related more to things that engineers are doing, like ponds. So SC, for example, is a sandy clay type soil. CL is a leaner clay. So most of the time, you probably won't be using these as often, just because it's getting more specific for engineering purposes. The next thing I wanted to look at was AASHTO. AASHTO is something that you will want to look for a lot of the things that you're going to be doing a subgrade for. So if you go to AASHTO group classification and we hit view rating, what this is going to do is it's going to give us an AASHTO for each soil group. And so what you see for your AASHTOs is it's usually an A dash some number. And that's really key. Um, so if we look here, there's actually a table that I have. It's really handy, and I can send this to you if you are interested in having this. Um, but in general, what I like to tell district staff to look for is you want your soil, if you're doing anything that has a subgrade. So maybe a road or a feeding pad, something that's the soil subgrade is really important, and it be able to hold up something of substantive weight. You're going to want something that has a general rating as a subgrade that's excellent to good. So that's going to be anything in an A1 group, an A3 group, or an A2-4, A2-5. Um, Anything else is fair to poor. At that point, you should probably call your local engineer. You should call your soil scientist because you're going to want to reconfirm that the AASHTO that is classified at that site is correct. Um, because if we're getting into the A7s, A6s, these clay soils, silty soils, um, that may require additional engineering. That may be a concern for you planning the practice, and you may want extra help, or you may want the district engineer to maybe take over this job completely, um, because it's going to require additional engineering to make sure that it's sound. The other thing that we're going to look at for AASHTO, other than the group classification, is you can look at the index. And so when we look at the AASHTO group index, it's right under the AASHTO group classification. And so if we look at this rating, it's going to give us a number rating. And so in general, a lower number is good. A higher number is bad. So these 11, the 16, those are bad signs. The higher the group index, the worse the material. So when I start seeing 7, 16, 11, those are, again, going to be those times where if I'm planning a practice that says that engineering properties are a concern, then I'm going to be looking at these rating numbers, and if I see something that's a 7 or more, maybe even a 6 or more, 5 or more, um, that's when I'm going to start thinking I need to contact someone else to make sure that the engineering plan that I have is going to be solid enough to support these soils, for these soils to support it, really. AASHTO takes into account both the liquid limit and the plasticity limit. And so when we're looking at the liquid limit and plasticity limit, those are under our soil's physical properties. So let's look at liquid limit first. So when we're looking at liquid limit means the number at which the water percentage of the soil is the minimal. So if I have 45% of a Bradson Gravely loam in our example or more, then at 45%, that's when I'm going to start water content. That's when I'm going to start expecting the soil to behave like a liquid instead of a plastic material or a solid material. So in general, the higher this liquid limit, the less likely it is to behave as a liquid, if that makes sense. So in general, we want things, for most engineering purposes, you want something that has a higher liquid limit. Plasticity limit you can find as well. So if we go back over here below on our soil physical properties, we're going to go down to plasticity index, where view our rating again here. It's probably going to ask you a depth range. So what are we looking at? For this, we're going to say surface layers, just as an example. Again, you're going to be looking at what depth are you looking at that you're going to be disturbing soils for your numbers. And again, we're getting a rating in percent. So these percentages will be less than what you would see for the liquid limit. So generally what we're looking at liquid limit and plasticity limit is they're related to each other. Liquid limit is going to be when the soil starts behaving as a liquid at this percentage of water. Below that, it's going to behave as a plastic material. So that means it's bendable, moldable. At that point, it's going to be more susceptible to being compacted when you're in these plastic levels. So in this case, when we're looking at these soils at 11% water for this Dillard loam type soil, that's when it's going to start behaving as a plastic. And then if we looked at the liquid limit, that's when it's going to start behaving as a liquid. So ideally, you're going to want to get soils that, again, have a higher rating percent. And all this factors into your AASHTO number as well. So AASHTO takes both of these into consideration when it's talking about a material that you're building off of. So a lot of times you may be able to look at the AASHTO number and get a better idea of how usable the soil is, but these kind of break down that as well, and they're part of that engineering properties that you may want to look at. The final thing that kind of pops up in this is our fragments. And so when we're looking at fragments of soil, that's going to go back into that when we're looking just at our soil map. And so when we're looking at our soil map, you're going to notice that some of the soils are going to say that they're gravelly loam. They may say that they're bouldery loam. And so when we're talking about fragments, it's just simply talking about, does it have any large rock pieces in that soil matrix that are making up part of our soil? And how much of that is. Is it a lot of gravel? Is it very bouldery? And that's going to take into effect what we can do with that soil as well.